Okay, good evening. Is it audible? Okay. Thank you. Okay, thank you. So last day we completed signal flow graphs. We started time domain analysis and we discussed what is the transient response and steady state response. Transient response is the one it becomes zero at time becomes very large. Steady state response means is a part of the time response that remains after the transients becomes the zero. After the transients becomes the zero. Okay, up to that it is completed. Next, today time response to the first order systems we'll discuss. Time response to the first order systems. 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 Satyam. So first order system responses are very easy. Only little, but generally the questions they used to ask in second order systems. 90% of the questions in the time domain analysis is from second order systems. Okay. Time response to first order system. Draw the block diagram to the first order system, all of you. Draw the block diagram to the first order system. R of S. Summing point. One by tau S. C of S minus. So this is the first order system. 1 by tau S. 1 by tau S. So this is the first order system, standard block diagram. Find the transfer function. C of S by R of S equal to 1 by tau S plus 1. Closed loop transfer function is 1 by tau S plus 1. 1 by tau S plus 1. Next. So here, what is the practical circuit for this? What is the order here? Anybody? Order is 1. Yes or no? What is the type here? First order system. Order is 1. What is the type? Anybody? Type. What is the type of the system? 0. 1, 1, 0. Type defined for only open loop transfer function. For type you have to observe G of S. Already I told. Type we have to observe open loop transfer function. For order you have to observe closed loop transfer function. For type you have to observe G of S. H of S must be 1. Not studying. So type is 1. A first order system having a type 1 and order 1. For order you have to observe the closed loop transfer function. For order you read the definition, the basics. For order you have to observe closed loop transfer function. For type you have to observe open loop transfer function, that is G of S. I told very clearly Still some people are telling wrong answer. And they're not studying. Eating, sleeping, and mobile 24 hours. You should study. Next, practical circuit. What is the practical circuit for first order system? Practical circuit. Practical circuit. What is the practical circuit? RC or RL, low pass filter. Low pass filter. Practical circuit is RC or RL, low pass filter. Draw the practical circuit. Draw the practical circuit. RC, V0, VI, R, C, R, LR, low pass filter. Low pass filter means it allows the only low frequency. Low pass filter means which allows the only low frequency. At low frequency, V naught equal to Vi. For example, at low frequency, frequency 0, what is the capacitor? Open circuit. Open circuit means V naught equal to Vi. So here also for low frequency, so for example, frequency 0, inductor short circuit. If it's short circuit, what is V naught? V naught equal to Vi. These two are practical circuits. For these two circuits, you find a transfer function. You will get the transfer function is 1 by S tau plus 1 only. Because these are low pass filters, 1 by S tau plus 1 only will get. 1 by S tau plus 1 you will get. Okay, na? It is a low pass filters. These are the practical circuit for this block diagram. Okay. Next, impulse response. Completed. Next, impulse response to the first order system. Impulse response. Impulse response. Already first order system heading you put it na. So now impulse response. So impulse response means R of t equal to what? Del of t. R of s equal to 1. R of s equal to 1. What is C of s by R of s? C of s by R of s equal to 1 by S tau plus 1. 1 by S tau plus 1. C of s by R of s equal to 1 by S tau plus 1. This is the transfer function. Now substitute R of s. So R of s equal to 1. Substitute R of s. R of s is 1. Now what is C of s? 1 by S tau plus 1. C of s is 1 by S tau plus 1. C of s equal to 1 by S tau plus 1. Then find the inverse Laplace transform. This can be written as, you can take it, tau take it common. Then what I will get? S plus 1 by tau. S plus 1 by tau. Apply inverse Laplace transform. C of t equal to 1 by tau e power minus t by tau. 1 by tau e power minus t by tau. So this is the what? Impulse response. So e power minus t by tau. It is called transient response. Transient response. It is a transient or steady state. E power minus t by tau is a transient response. Impulse response consists only transient term. Impulse response. Impulse response consists transient term. Transient term consists system parameter. What is the system parameter here? Tau. Tau is the system parameter. Impulse response consists the transient term. Transient term consists the system parameters. System parameters. What are the system parameters? Already I told. K and tau are system parameters. K and tau are system parameters. K comma tau are system parameters. Impulse response consists the transient term. Transient term only, na? Substitute it and exponential term represents the word transient. It consists the system parameters K and tau. Here K1, that's why K term not there. Only because here tau we consider, here also tau we got it. That's why the impulse response, as impulse response consists only system parameters. The impulse response is also called, I told it already, system response, natural response, or free forced response, free forced response. System response, natural response, or free forced response. So be remember, impulse response is also called system response, natural response, or free forced response. I already discussed in the basics. Now draw the response. Draw the response. So this is T, this is C of T, this is C of T. T0, where it starts? 1 by tau. T0, it starts at 1 by tau. 1 by tau. Substitute T0 here. Substitute T0, this will become 1. So 1 by tau. T infinity, e power infinity become 0. That means exponential decay. Exponential decay, like this. Exponential decay. Reach the steady state by 5 tau. Reach the steady state by 5 tau. Reach the steady state by 5 tau. What is the nature of the system here? System nature is what? Exponential decay. What is the system still? 100% it is a stable system. 100% it is a stable system. So this is the what? Impulse response. Can you find the steady state error for impulse input? Anybody? Can you find steady state errors for impulse input? Can you find steady state error for impulse input? Yes, very good. 0. No. Yes. So we cannot find steady state error for impulse input. What is the definition of error? Tell. Error equal to what? Error definition. Error equal to what? Input minus output. Input minus output. Error is input minus output. Error definition is input minus output. That is E of t equal to R of t minus E of t. R of t minus E of t. R of t minus E of t. So now find steady state error. Find the steady state error. So ESS is called steady state error. ESS is called steady state error. Steady state error. ESS equal to limit t tends to infinity E of t. So that equal to limit t tends to infinity. What is E of t? R of t minus E of t. R of t minus E of t. R of t minus E of t. So now tell what is R of t? For impulse, what is R of t? Del of t. What is C of t? 1 by tau e power minus t by tau. But where you have to write R of t? At infinity. R of t at infinity. What is R of t at infinity? Not exist, because impulse exists only at where? Impulse exists only at t equal to 0. Other than t equal to 0, there is no input. Other than t equal to 0, there is no input. No input. Other than t equal to 0, there is no input. As well as there is no output. At t infinity, there is no output also. Is there any steady state term here? There is no steady state term. At phi tau itself become 0. After phi tau almost 0. That means there is no input as well as there is no output exists at t tends to infinity. At t tends to infinity, no input is there, no output is there. That's why we used to say that steady state error for impulse input is not defined. Generally, there is a separate topic for steady state errors. Steady state errors we used to study for step input, that is called Kp, and ramp input, that is called Kv. Position error constant, it will come later, it will come. Ramp input, velocity error constant, parabolic, acceleration error constant. But there is no input for the what? Impulse, because it is not defined. It is not defined. Steady state errors for impulse input is not defined. Steady state errors for impulse input is not defined. For impulse input is not defined. For impulse input is not defined. For impulse input. Impulse input is not defined. Impulse input is not defined. చెప్పండి 1 minute. లేచే అయిపోయింది సార్, ఇన్స్టాల్ చేసుకున్నాం. ఓకే ఓకే సార్. రైట్. సో steady state error for impulse input is not defined because there is no input and output exist at t tends to infinity, because there is no input and output. There is no input and output exist at t tends to infinity. Exist at t tends to infinity. Steady state error for impulse input is not defined because there is no input and output exist at t tends to infinity. At t tends to infinity, there is no input as well as there is no output. That's why steady state errors for impulse input is not defined. ठीक है ना भैया? Or we can say other term. Infinity means steady state. Infinity, t tends to infinity means steady state. The response does not consist the steady state term. Is there any steady state term here? No steady state term. So we cannot perform steady state analysis. The other way also you can tell. Or impulse response does not consist steady state term. Impulse response, the best is first one only, because there is no input output exists at t tends to infinity. We cannot define steady state errors for the what? Impulse input. That is the best instead of this. Okay. Next. ठीक है ना? So be remember, impulse response is also called what? Impulse response. Impulse response is also called as system response, or natural response, or free forced response. ठीक है ना? Next. So this is about the impulse response. Next, unit step response. Come on. Next, step response. Unit step response. Unit step response. Unit step response to the first order systems. Unit step response. Unit step response to the first order systems. Come and do it. Unit step response you find. What is R of t? Tell. What is R of t? Come on. What is R of t? 1 into u of t. Unit step means. 1 into u of t. R of s equal to 1. R of s equal to 1 by s. C of s by R of s equal to what? 1 by s tau plus 1. Now substitute R of s. If you substitute R of s, it becomes what? If it is substitute here R of s, take it other side. 1 by s into s tau plus 1. 1 by s into s tau plus 1. Now find partial fractions. Now find partial fractions. C of s equal to, find the partial fractions. S equal to 0, substitute s tends to 0. If s equal to 0, what you are getting? Partial fractions. If s equal to 0, if substitute first term become 0, then it will become 1. So that means 1 by s. 1 by s. S equal to 0, then you will get 1 by s minus. So s tau plus 1 equal to 0. S equal to minus 1 by tau. Minus 1 by tau substitute here. If I substitute minus 1 by tau, here what I will get? Substitute minus 1 by tau. S tau plus 1 equal to 0 means s equal to minus 1 by tau. Na? You substitute in the s minus 1 by tau. What you will get? Minus tau. So minus tau by partial fractions. Minus tau by tau s plus 1. Tau s plus 1. Or you take a by s plus b by s tau plus 1. Get the a and b values. You will get a1 b minus tau. Now apply. This can be written as 1 by s minus tau by denominator tau, take it common, s plus 1 by tau. Tau cancelled. Now apply inverse Laplace transform. What is inverse Laplace transform? Tell. C of t equal to 1 minus 1 by s plus 1 by tau means what? E power minus t by tau default u of t. Default u of t. So 1 e power minus t by tau default u of t. Yes or no? Here 1 is a steady state term. 1 is steady state term. And e power minus t by tau is transient term. Transient term. Transient term. Yes or no? So this step ramp parabolic response consists the what? Steady state term as well as transient term. Generally steady state term will get because of input. Steady state term is because of input. Transient term is because of the system generally. Generally in the response, in general in the response, steady state term is because of input. Steady state term because of the input. In general, steady state term. In general, steady state term. SS means steady state. Steady state term because of input. Because of input. And transient term. Transient term because of the system. Transient term is because of system. Be remember, because of system. That also stable system. So first order system minus 1 s tau plus 1 means pole is minus 1 by tau. It is a stable system only. Okay, na? Because of the system. That's all. Okay. So now draw the response. Now draw the response for 1 minus e power t by tau. You draw the response for 1 minus e power t by tau. Draw the response. If you draw the response, what I will get? So this is t, this is t, this is c of t, c of t. This is 1. This is input, unit step input, na? This is 1. Now draw the output. What is the output? Tell here. Output is, come on, substitute here t equal to 0. What I will get? E power 0, 1. 1 minus 1, 0. That means it starts from 0. Next, t infinity. Infinity substitute here. E power minus infinity, how much? 0. That means it rises to 1. That means the response goes to 1. The response like this goes to input. So output reaches the input here. That means what is the steady state error? 0. This is the output. This is C of t. C of t means output. This is C of t, output. This is input, R of t. So R of t minus C of t at t tends to infinity, both are same. That means error equal to 0. No sir, I will find means you find. What is the formula for ESS? Limit t tends to infinity, R of t minus C of t. R of t minus C of t. So come on, limit t tends to infinity. What is R of t? 1. Minus what is C of t? C of t also what happened? R of t 1 and C of t is what? 1 minus e power minus t by tau. C of t, yeah. C of t, what is C of t? 1 minus e power minus t by tau. Now substitute t tends to infinity. Default u of t. Substitute t tends to e power minus infinity 0. 1 minus 1 becomes 0. So steady state error is 0. That only I written here. The error equal to 0. Steady state error becomes the 0. Error is 0. So because the output reaches to the input, the error becomes the 0. This is unit step response. Okay, na? It is a unit step response. But here, listen all of you. Very important thing. Listen. See, generally, a stable system is the one it follows the input. The stable system is the one it follows the impulse. You see, impulse response, you see, it goes to 0 because input is 0. Impulse other than t equal to 0, 0 na output also moving towards the 0. Input step na it going to towards the step. Impulse means always response. Stable system follows the 0 only. But step means it follows the what? In ideal case, it follows the 1. Unit step means it follows the 1. But what is the steady state value means here? What is the steady state value here? 1 is the steady state value. This steady state value depends on system gain as well as input. When the input is step, the steady state value is nothing but A and K. A is called amplitude of input. K is called system gain. For example, see, for example, I'll take a step signal. I'll take a step input, for example, R of t. That is A into U of t I'll take, not unit step. I don't take ideal case. For example, I'll take A into U of t. Even previous case, I take a system gain also 1. What is the system gain here? Numerator constant by denominator constant means what is the system gain? 1. So I don't take system gain also 1. For example, I'll take and C of S by R of S I'll take. For example, K by S tau plus 1. S tau plus 1. Then what is the steady state value? What is the steady state value? What is the output you will get, you know? What is R of S tell here? R of S become A by S. R of S become A by S. A by S. Now write C of S. What is C of S tell? C of S becomes A by S means A K by S into S tau plus 1. So you find partial fractions. S0 means AK you will get. AK by S. S0. You substitute here S0. AK by 1 means AK. So AK by S. Now S tau plus 1 0. This you make it 0. If this make it 0, then S equal to minus 1 by tau. Substitute you will get minus AK tau by S tau plus 1. Again this can be written as AK by S minus AK tau we can take tau common and get the cancel. S plus 1 by tau. That means tau tau cancel. If I apply inverse Laplace transform, what is C of t I am getting? Tell AK into, so AK minus AK into e power minus t by tau you will get. Default u of t. So take AK common. If you take AK common, 1 minus e power minus t by tau. Default u of t. This is the output. Ideal case, what previous case, what I did, I taken A is 1. In this case, A is 1. K also 1. K also 1. That's why steady state value got it 1. Steady state value means t tends to infinity substitute. T tends to infinity by substitute. What happened? This will be 0, 1. 1 we are getting. But practically in the sometimes they used to ask it. So what is the steady state value for step response? Steady state value for step response decided by amplitude of input and system gain K. Steady state value, for example, t tends to infinity, what you are getting? AK you are getting. A is called what? Amplitude of input. K is called what? System gain. K is called system gain. So if it is a closed loop system, then it is closed loop system gain. If it is an open loop system, then it is open loop system gain. Okay, na? So steady state value for step input, the steady state value depends on, for step input, the steady state value is depends on amplitude of input, that is A, and system gain K. That means here what I did, 1 year written, but actually here what you have to do, you have to write AK. If I draw the response here, for example, how to draw? This is T, this is C of T. Then what is the steady state value? AK. That means this is called AK. Input is 1. Input is 1. Forget the input is A, na? Input is A. Input is A, U of T. But output goes to what? AK. Output where it ends at the steady state means AK. That depends on the value of AK. Output it moves like this. It may be even more than input or less than input final. That depends on what? This is called AK. It may be even more than input. It may be less than input. So that depends on the K value. So AK is the final value for step input. Okay, na? So ideally one only, but practically depends on steady state value for step input. It depends on amplitude of input and system gain K. Be remember, AK, it end at AK. Some people unit step response means they used to think that it end at 1. Wrong. It end at AK. A is called amplitude of input. K is called system gain. Be remember, system gain. Okay, na? I hope you understood. Okay. 95% of questions on only step response. Generally, they'll ask the questions on step response of either first order, second order. Worst case, rare cases, they used to ask on impulse. Till now, they didn't ask any question on the ramp and parabolic. Generally, they don't ask questions on ramp and parabolics. So, the most widely used test signal also step input only. That's why most of the questions even they used to ask it on only step input. You observe the previous gate and IES questions that belongs to either impulse or step only. Okay, na? So I hope you understood. Next, unit ramp response. Unit ramp response. R of t equal to A into T into U of t. R of S equal to A by S square. R of S equal to A by S square. A by S square. R of S equal to A by S square. C of S by R of S equal to C of S by R of S equal to 1 by S tau plus 1. 1 by S tau plus 1. C of S equal to, bolo. You take unit na, A is 1. Generally, they'll ask ideal case only. A is 1. So 1 by S square. Then C of S becomes what? 1 by, bolo, S square into S tau plus 1. Then find the partial fractions. Then find partial fractions. Come on. Find the partial fractions, all of you. Right. Come on, do it. Partial fractions. What is the partial fractions? Tell this can be written as A by S square plus B by S plus C by S tau plus 1. C by S tau plus 1. S tau plus 1. So, partial fractions is A by S square plus B by S plus C by S tau plus 1. S tau plus 1. Come on, now get the partial fractions. A value find. This can be written as 1 by S square into S tau plus 1. That equal to LCM you take here. What is LCM? S square into S tau plus 1. So A into S tau plus 1 plus B S into S tau plus 1 plus C into S square. C into S square. Now find partial fractions. What you will get here? This denominator terms both get the cancel. Then compare S power 0 coefficient left and right. Compare S power 0 coefficient. Left is 1. Right is what? A. Left is 1. Right is A. Next, S power 1 coefficient. S power 1 coefficient. Come on. What is S power 1 coefficient? 0. Left side 0. Right side A tau. Right side A tau plus B. A tau plus B. Tau is 1. A is 1. So B equal to what? Minus tau. Next, this is B equal to minus tau. Next, S square coefficient you compare. Left side is 0. Left side no S square coefficient. Right side what? Equal to bolo B tau. B tau plus C. B tau plus T. Tau B equal to minus tau. That means C equal to tau square. Like this you have to find. This is standard procedure of finding partial fractions. So like this you have to find ABC value. Then we can write it as what? Then we can write C of S equal to what you can write? 1 by S square. 1 by S square minus tau by S. Minus tau by S plus tau square by tau S plus 1. Tau square by tau S plus 1. Now find, come on. Now find inverse Laplace transform. This can be written as, C of S can be written as 1 by S square minus tau by S plus tau square by tau, take it common, S plus 1 by tau. Tau cancel. Then apply inverse Laplace transform. So what you are getting? Or one more time you write. What is C of S? C of S equal to 1 by S square minus tau by S uh, 1 by S square minus tau by S plus tau by S plus 1 by tau. Tau by S plus 1 by tau. So apply inverse Laplace transform. So C of t equal to t minus tau plus tau e power minus t by tau. Default u of t. Default u of t. So now take, this is called steady state term. This is called steady state term. This is transient term. Transient term. Transient term. Now draw the response. Now draw the response. We write C of t here. C of t is C of t is t minus tau plus tau e power minus t by tau u of t. So now draw the response. Before drawing the response, you find the steady state errors. You find the steady state error. You find the steady state error. What is the formula for steady state error? Limit t tends to infinity r of t minus c of t. R of t minus c of t. R of t minus c of t. So that equal to limit t tends to infinity. What is r of t? R of t is t minus what is c of t? Here itself is there. T minus tau plus tau e power minus t by tau. So then tau cancel, tt cancel. E power minus infinity 0. So minus minus bit plus. Then the answer is tau. The answer is tau. So steady state error is tau. Now draw the response. Now draw the response. So you draw the response. Come on. Error is tau. This is t. This is c of t. 0. This is r of t. 1t u of t. So now draw the output. You draw the output. What is the output? Tell. You draw the output. C of t you draw. Come on. T equal to 0. What you will get? T equal to 0 means e power minus infinity 0. T equal to 0. T equal to 0 means this is 0. E power 0, 1. T 0 means this is 0, na? So this will become 1, na? So plus tau minus tau cancel. That means it will become 0. T infinity. T infinity means this is 0. What is left? T minus tau left. T infinity means this is 0. What is left? T minus tau left. T minus tau. So T is called input. T is called input. From input, it is deviated by tau. Where? At infinity. But practically, infinity cannot represent. Practically, what is the value? Infinity means 5 tau. Practically, it is a value of 5 tau. 5 tau is called, they represent infinity. Practically, 5 tau is called steady state. So now draw it. At the steady state, what is the response? Tell. At the steady state means at the phi tau. At the phi tau, what is the output tell? At the phi tau, e power minus phi tau, if I substitute tau tau cancel, e power minus 5 value, e power minus 5 value approximately 0 only. E power minus 5 value approximately 0. That means this term becomes 0. What is left? T minus tau left. T minus tau left. T minus tau left. So come on, draw the T minus tau. T is the input. From the input, it's subtracted by tau. This is T, na? This is T. From the T, the output is less by the factor of tau. The output is less by the factor of tau. This is T. The output is less by the factor of tau. By the factor of tau. So now draw a line like this. So wherever you observe, this is the line of what? T minus tau. Because from T subtracted the factor of tau, na? So that means this is called T minus tau. This will be continued parallel to this. At any instant you observe, the difference is tau only. That's why we got steady state error is how much you got? Tau. So the difference is tau only always. After phi tau, you observe the difference between input and output, that will become tau. That is called steady state error. This is the line of T minus tau. Dear T minus tau. So T minus tau. Now join this two. Join this two. Then it is called the output. Just join this two. Whenever you want to draw the response, find the value at T equal to 0. Find the value at phi tau. Join it. That will become the output. This is called C of T. This is called C of T. This is a C of T. This is C of T. C of T. This is called C of T. C of T. Okay. So this is the output. This is the input. So like this, you have to draw the response for unit ramp input. Unit ramp input. Okay, na? This is the ramp response. Okay. So next. Parabolic response. Unit parabolic response. But parabolic response homework not only for you, for all the students, I am giving homework only. So you also take homework. Okay. So unit parabolic response. Just I'll give the idea. Unit not only for your batch. I am giving homework this unit parabolic response because some people don't know how to find partial fractions. Till now there is no question, but you should know. Compulsory should solve. Unit parabolic response. This is homework for all the batches from 2002 onwards, not only for you. So that at least who don't know partial fractions, they will learn. So R of T equal to what? Tell parabolic input 1 T square by 2. U of T. This is the standard form of parabolic input. R of S becomes what? 1 by S cube. And C of S by R of S malum na? C of S by R of S is what? 1 by S tau plus 1. Now substitute C of S. R of S is substitute. If you substitute R of S, it will become 1 by S cube into S tau plus 1. 1 by S cube into S tau plus 1. Then, come on. Now, what I have to do? Partial fractions. A by S cube plus B by S square plus C by S plus D by S tau plus 1. So now find ABC values, do in your home and find the C of T. Find ABC values. Okay. Do in your home. Find inverse Laplace transform. I think A1 will get. A1 will get. B is minus tau. You solve it. C is tau square, I think. D is minus tau cube. Compulsory solve it. Then if apply inverse Laplace transform, I think you will get. So 1 by s cube means what? T square by 2. 1 t square by 2 minus tau t plus tau square minus tau square e power minus t by tau. Will get, I think, default u of t. So whatever it is here, steady state error becomes infinity. Steady state error becomes infinity because at t tends to infinity, it becomes infinity, na? So this term will be there, error becomes infinity. If you draw the response, this is t, this is c of t. The input is like this. This is parabolic input. So this is the parabolic input r of t. That is 1 t square by 2 into u of t. Then find the output. What is the output? Tell. Output is like this. So the deviation go on increases like this. Then the error becomes the what? Infinity. This is the output. The error go on increases so that the steady state error becomes the infinity. But till now, there is no single question on parabolic response, but you should know. So like this, you have to draw it. Okay? Right. Next. So this is about the first order system responses. First order system responses are very, very easy. First order system responses are very, very easy. So generally, second order systems only they used to ask. And questions also, most of the questions they used to ask on second order. First order system, simple step important. T0, it is 0 only, na? Substitute T0, yeah? This is 0, this is 0. This will become what? 1. Tau square cancel. That's why it starts from 0. Output also starts from 0. Input also starts from 0 only. Okay? So starts from 0 only. Next, second order system response. It is very, very, very important. First order system is just substituting input, finding output. That's all. Nothing is there. First order system is substituting input, finding the output. That's all. Nothing is there. Most of the concepts you'll get in only second order system. So listen, second order system. Time response to second order systems. Time response. Time response to second order systems. Time response to second order systems. Okay, na? Second order systems. So now draw the block diagram for the second order system. Draw the block diagram for second order system. Draw the block diagram. So R of S, summing point, omega n square by S into S plus 2 zeta omega n C of S. This is the block diagram for the second order system. What is the type and order here? Anybody? What is the type and order? Type is 1, order is 2. Very good. Type is 1, order is 2. Correct. Right, listen. So type is 1. Type written for G of S only. It is type 1 system. Type 1 system. For type you have to observe only G of S. H of S 1. So now find closed loop transfer function. C of S by R of S. Then you can write order. What is C of S by R of S? Omega n square by S square plus 2 zeta omega ns plus omega n square. S omega n square by S square plus 2 zeta omega ns plus omega n square. Okay. So this is the second order system. Next, what is the order tell here? Order is 2. What is the practical circuit? Practical circuit for order required closed loop transfer function. This is closed loop transfer function. Practical circuit, anybody? Practical circuit. Practical circuit. Practical circuit for second order system is RLC low pass filter. RLC low pass filter. RLC low pass filter. Draw RLC low pass filter. RLC low pass filter. Now this is SL. This is 1 by SC. This is V naught of S, VA of S. Find the transfer function. Come on, find transfer function. V naught of S by VA of S equal to, come on, impedance across output 1 by SC by total circuit impedance R plus SL plus 1 by SC. Now simplify this. What you will get if you simplify this? Come on. You simplify this. 1 by here S square. S into S, S square na. S, 1 by S cancelled. S cancelled. S into S, S square. S square LC plus SCR plus 1. Now divide with LC. Divide with LC. Now what happens if you divide with LC? 1 by LC divided by S square plus S into divide with LC. 1 by LC na. So here S square, here S into LC means R by L na. R by L plus 1 by LC. 1 by LC. S into R by, correct. Yes or no? So divide with LC na, we divide with LC. So 1 by LC, here 1, here R by L, 1 by LC. Now compare these two. Just compare these two. Compare. Both are same na? Compare. 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 Come on. If you compare it, what is omega n? Compare it. Come on. If you compare, what is omega n? What is omega n? Omega n is 1 by root LC. Very good. What is zeta? What is zeta? Come on. So here compare omega n equal to 1 by root LC. Radians per seconds. It is called natural frequency of oscillations. Natural frequency of oscillations or sustained. Already I told all this word. Sustained oscillations or below. Another word tell steady state oscillations. Steady state oscillation, undamped oscillations. steady state oscillations, steady state, or undamped oscillations, undamped, all are same. Next, find zeta. 2 zeta omega n equal to R by L. 2 zeta omega n equal to R by L. Now find zeta. Zeta equal to what? R by 2 L into omega n. Substitute omega n value. Substitute omega n. Ante root LC, I think you will get here. Root LC. So that means what is zeta? Zeta equal to R by 2. Root will get denominator. So root of C by L. Root of C by L. This is zeta. Zeta is known as what? Zeta is known as damping ratio. Zeta is known as damping ratio. Damping ratio. Zeta equal to damping ratio. Zeta is known as damping ratio. So damping ratio. Damping ratio. Zeta is known as damping ratio. So damping ratio, it gives the ratio of what? Energy lost to energy stored. It gives the ratio of energy lost to energy stored. Energy lost to energy stored. Energy stored. Energy stored. So zeta omega n is called what? Zeta omega n is called damping factor. Zeta omega n is called damping factor or actual damping. Damping means decay, yeah. Actual damping, that actual damping. So actual damping. Damping means decay because zeta omega n is called 1 by zeta omega n is called time constant. It will come, time constant is 1 by zeta. It will come later. So it is called the damping factor or actual damping. Okay. So next, second order system response completely depends on zeta. Second order system response or nature, whatever it is, depends on only zeta. Depends on only damping ratio. Depends on only damping ratio. That is what zeta. Damping ratio. That is what only zeta. Second order system response depends on only damping ratio. Zeta. Zeta. So it is completely depends on zeta only. Okay, na? So not only response, even stability. Second order system stability. Second order system stability. Second order system stability. Second order system stability depends on zeta. So second order system is stable. Second order system is stable. System is stable. Is stable for all the values of zeta greater than 0. For all the values of zeta greater than 0, because poles lies in the left of S-plane. Because poles lies in the left of the S-plane. Left half of the S-plane. Left half of the S-plane. Second order system is stable for all the values of zeta greater than 0 because poles lies in the left half of the S plane. I'll draw a diagram. I'll draw the diagram. Okay. So here, so here j omega axis. So when zeta equal to 0, poles lies on imaginary axis. Poles lies on j omega axis. Zeta equal to 0, poles lies on j omega axis. System is marginal stable. System is marginal stable. Zeta greater than 0. Zeta greater than 0. Zeta greater than 0. Poles lies in the left half of S plane. Left half of S plane. System is stable. Zeta greater than 0. Poles lies in the left half S plane. System stable. Zeta less than 0. Zeta less than 0. Poles lies in the right half of the S plane. In the right half of S plane. System is unstable. Zeta less than 0. Poles lies in the right half of the S plane. System is unstable. That means second order system is stable for only zeta greater than 0 because the poles lies in the what? Left half of the S plane. So right side unstable. Imaginary marginal stable. Okay, na? So whatever the input, it is secondary. It may be impulse, it may be step, any input. Zeta greater than 0 means the system is stable because the poles lies in the left of the S plane. Zeta less than 0 means poles lies in the right, system unstable. Zeta 0 means the poles lies on imaginary axis, the system becomes the marginal stable. Okay, na? Right. Next, go for impulse response. Come on. Next, go for impulse response. Zeta greater than 0 means up to infinity. For all the positive values of zeta, second order system stable. Next, impulse response to second order system. Come on, Guruji. All of you solve it now. Come on, Bhaiya. Come on. Do it. Do by yourself. Come on. Damping ratio R by 2 root of C by L. Very good. Come on. Impulse response. What is del of T? 1. Del of T is what? R of T equal to del of T. R of S equal to what? Come on, bolo. 1. Next, C of S by R of S. You should do. Same thing, just like first order, omega n square by bolo. Omega n square by S square plus 2 zeta omega ns plus omega n square. Omega n square by S square plus 2 zeta omega ns plus omega n square. Next. Come on, now substitute R of S. Then C of S becomes what? Omega n square by S square plus 2 zeta omega ns plus omega n square. So now case 1, you have to take the different values of zeta, you have to draw the response. You have to take the different values of zeta. You have to draw the response. Now, case 1. Case 1. Zeta equal to 0. Undamped system. Zeta equal to 0. And why it is called undamped system, I will discuss later. Why it is called undamped system, then I will discuss later. After some time it will come. So first case zeta 0. Substitute zeta 0 here. You substitute 0. Find C of S and locate the poles in the S plane. Come on. Substitute zeta 0. Zeta 0. What is C of S if zeta 0 bolo? Omega n square by S square plus omega n square. S square plus omega n square. Next, locate the poles in the S plane and draw the response. Locate the poles in the S plane. What I will get here? What are the pole locations? S equal to plus or minus omega plus or minus j omega n. Locate in the S plane. Locate in the S plane. Come on. S equal to what? Plus j omega n. This is plus j omega n. Other one minus j omega n. Minus j omega n. Now find the time constant. Now, what is the time constant tell here? Time constant. Tau equal to what? Minus 1 by 0. Time constant. Tau equal to minus 1 by real part of the pole is 0. So that equal to minus infinity. But time constant should not be negative. So that means infinity. Undamped system having time constant is infinity. Imaginary part gives the what? Frequency of oscillation. All these things already I covered. Imaginary part gives the frequency of oscillation. What is that? Omega n. Radians per second. Non-repeated pole on imaginary axis. Marginal stable. Non-repeated pole. Non-repeated poles on j omega axis. On j omega axis. System is what? Marginal stable. System is marginal stable. Non-repeated poles on j omega axis. System is marginal stable. Marginal stable. Now find the C of t. Now find the C of t and draw the response. Find the C of t and draw the response. What is C of t? Tell. Find C of t. What is C of t? Omega n into sine of omega n t. Yes or no? Default u of t can write. Simply sinusoidal oscillations. Sinusoidal oscillations simply. Yes or no? Sinusoidal oscillations. So draw the response. This is C of t. This is t. This is 0. So this is the what? Sinusoidal oscillations. So these are called what? Constant amplitude. I already discussed. Constant means constant peak amplitude, constant amplitude, and frequency of oscillations, and frequency of oscillations, frequency of oscillations, which are called undamped oscillations. Damping means decreasing amplitude, like this. These are called damping. It is not damping, not damping. That's why it is called undamped oscillations. Undamped oscillations. Another name just now only I written. Sustained oscillations, steady state oscillations, natural frequency of oscillation. Already I written, na? Undamped oscillations, sustained oscillations, steady state oscillations, sustained oscillations, sustained oscillations, natural frequency of oscillations, NFF, NFO, natural frequency of oscillation, denoted by the letter of what? Omega n radians per second. Just now only I written. Because it is giving undamped oscillations, because it is giving undamped oscillation, the system is called what? Undamped system. Name of the system selected based on the nature only. Nature is undamped oscillation. That's why it is called undamped system. When zeta 0, the poles always lies on imaginary axis, which are non-repeated, and the system response is constant amplitude and frequency of oscillations, which are called undamped oscillations, and the system is called undamped system, and then it is a marginal stable system. It is a marginal stable system. Okay na? Okay na? So write it. Now write when zeta equal to 0, when zeta equal to 0, when zeta equal to 0, the poles lies on j omega axis. The poles lies on j omega axis, which are non-repeated, which are non-repeated, which are non-repeated, which are non-repeated, which are non-repeated. This system is marginal stable. This system is marginal stable. This system is marginal stable. The system response is, the system response is, the system response is constant amplitude, constant amplitude, and frequency of oscillations, frequency of oscillations, which are called undamped oscillation, which are called undamped oscillations. And the system is undamped system. System is undamped system. Okay? The system is called undamped system. Okay? Right. Next. Can you find the steady state errors? When zeta equal to 0, can you find the steady state errors? Anybody? When zeta equal to 0, can you find the steady state errors? When zeta equal to 0, can you find the steady state error? Anybody? We cannot find because system is marginal stable. Steady state errors are valid for only closed loop stable systems. When zeta equal to 0, we cannot find steady state errors. We cannot find Steady state errors. Steady state errors. When zeta equal to 0, we cannot find steady state errors because the system is marginal stable. Because the system is marginal stable. Marginal stable. Steady state errors are valid for only closed loop stable systems. Valid for only closed loop stable systems. Closed loop stable systems. This is about the impulse response when zeta equal to 0. ठीक है ना? Next case 2. Come on, do it. Case 2. What is the case 2? Zeta greater than 0, less than 1. This case very important. This system is called what? Underdamped system. Underdamped system. Underdamped system. Underdamped system. When zeta greater than 0, less than 1, the system is called underdamped system. Underdamped system. Come on, do it. Find the roots of the system. Why it is called underdamped, it will come. What is C of S? Tell. Omega n square by S square plus 2 zeta omega ns plus omega n square. Find the roots for the denominator, all of you. Find the roots. Come on, Bhaiya. Find the roots, all of you. Abdul.
Sir, this indaga page elan sir. Indaga 11F. 11F.
Tell.
ఇక్కడ మనం R of S మనం కన్సిడర్ చేయమా సార్?
R of S 1 కదయ్యా.
1/s కదా సార్.
ఏ ఇన్పుట్?
ఇది ఇంపల్స్.
ఇంపల్స్ R of S ఎంతయా?
1. ఓకే.
ఓకేనా?
del of t, u of t. del of t అంటే u of t ఒక 1 కదా సార్?
del of t అంటే ఇంపల్స్ రా నాయనా. u of t అంటే స్టెప్ రా నాయనా. ఇంపల్స్ del of t నా, స్టెప్ u of t.
ఓకే. ఇప్పుడు అది నెక్స్ట్ పేజ్ వెళ్ళండి సార్. 11F వెళ్ళండి సార్.
చెప్పు
సార్. ఇది డైరెక్ట్ ఇది మనం డైరెక్ట్ పోల్స్ ఈక్వల్ టు 0 తీసుకున్నారా?
మళ్ళీ అంతే కదా. పోల్స్ ఎలా వస్తాయి? వాట్ ఇస్ ద డెఫినేషన్ ఆఫ్ పోల్స్? రూట్స్ ఆఫ్ డినామినేటర్.
ఓకే సార్.
సరే, ఓకే, కంటిన్యూ ఇట్. కమ్ ఆన్, డూ ఇట్.
ఓకే.
Come on, find the roots. All of you completed? Tell the roots. Anybody? What are the roots? Minus zeta omega n plus or minus root of zeta square minus 1. Very good. Right. So find the roots. S1, S2 minus. How to find the roots? Minus b plus or minus root of b square minus 4ac by 2a minus b minus 2 zeta omega n plus or minus root of b square. B square means 4 zeta square omega n square b square minus 4ac 4 a1c omega n square divided by 2a. A is 1. 2a. A is 1. Now simplify this. To simplify this, bolo 2 here 2 here 4. Take it common. So 4 cancel. Now 4 outside it come 2. Total 2 we can take it common. Then 2 to cancel. What I am get? Okay. Minus zeta omega n plus or minus omega n square come outside become omega n. Already 4 came outside and cancelled with 2. Then what is left inside? Zeta square minus 1. So minus zeta omega n plus or minus root of zeta square minus 1. But this is valid only when zeta is greater than 1. But we are having zeta less than 1. Zeta less than 1 means what I will get earlier? Zeta less than 1 means zeta square become less than 1. That means it will become negative. Negative means you will get the imaginary. That means minus zeta omega n plus or minus j omega n root of 1 minus zeta square. 1 minus zeta square. Imaginary will get because zeta become negative na. Root of minus 1 become j. So j omega n root of 1 minus zeta square. So this is valid when zeta what? Greater than 0, less than 1. This is valid zeta greater than means this is fourth case I will use. For fourth case I will use minus zeta omega n plus or minus omega n root of zeta square minus 1. Now come on, represent the poles in the S-plane. This poles you represent in the S-plane. You represent it. Real part is minus zeta omega n. Imaginary part is plus j omega n root of 1 minus zeta square. Here minus j omega n into root of 1 minus zeta square. Root of 1 minus zeta square. Okay, na? These are the pole locations. Now tell what is the time constant? Time constant equal to tau equal to what? 1 by zeta omega n. Minus 1 by minus zeta omega n means what? 1 by zeta omega n. Na? Time constant tau equal to 1 by zeta omega n. 1 by zeta omega n seconds. This is the time. What is the frequency of oscillations? The imaginary part represents the what? Frequency of oscillations. Frequency of oscillation denoted by actually omega d, which is called damped oscillation. That is omega n into root of 1 minus zeta square. Radians per seconds. Radians per second. Omega d equal to omega n root of 1 minus zeta square radians per second, which are called damped oscillations. The poles lies in the left hand side, the system is stable. The poles lies in the left hand side, the system is stable. Now find the system response. Come on, C of S can be written as, it can be written as what? Omega n square by S plus zeta omega n minus j omega n root of 1 minus zeta square. Into S plus zeta omega n plus j omega n into root of 1 minus zeta square. So this can be written as what? This is like A minus JB, A plus JB. That means A square plus B square. That means this can be written as omega n square by S plus omega n, S plus zeta omega n whole square. S plus zeta omega n whole square plus omega n square root of, okay, మొత్తానికి whole square తీసుకుందాం. Omega n 1 minus zeta square whole square. Find inverse Laplace transform to this. Come on. But in the numerator, what should, this is like what? Laplace of, this is like Laplace of what? E power minus at sin bt. I told already. That means it is like, it is Laplace of e power minus at sin bt is b by s plus a whole square plus b square. Same form, na? This is b square s plus a whole square. Numerator b should be there. That means omega n root of 1 minus zeta square should be there. You adjust it, multiply and divide with root of 1 minus zeta square. For example, I can write the C of s equal to what I can write? Omega n divided by root of 1 minus zeta square I can write. And I can write omega n, I can product with root of 1 minus zeta square. Now we simplify this, you will get omega n square only. I divided product with root of 1 minus zeta square. And denominator same, na? S plus zeta omega n whole square plus omega n root of 1 minus zeta square whole square. Apply inverse Laplace transform. Then write C of t. What is C of t? Tell. Omega n by root of 1 minus zeta square. E power minus zeta omega n t. Sine of, I can write omega, this is called omega d only. Sorry, omega n root of 1 minus zeta square into t. Default what you can represent u of t. That means the signal is t greater than 0. U of t means t greater than 0. Here we can write. Here you can write u of t 1. U of t means t greater than 0. That's all. Okay. So what is this nature is called? This is exponential decay. This is sinusoidal oscillations. It is called exponential decay and frequency of oscillations, which are called damped oscillations. Which are called damped oscillation, denoted by omega d. Any system which produces damped oscillations is called underdamped system. Maintaining damping is called underdamped system. So if I draw the response, how to draw the response? So first it should be product of exponential decay and sine. Na? Draw the response. First exponential decay. This is exponential decay. Product with sinusoidal oscillations. Come on, draw the response. Draw the response. For example, say I'll take this is plus 1. This will take minus 1. Here take 10, 9, 8 and here 0. Just product it, that's all. So 0 into 10 becomes 0. Here 0 into 10 becomes 0. Next plus 1 into 9. It goes to 9. Next again minus 1 into 8. For example, this peak matches to this values. Minus 1 into 8, it will come to minus 8. Next plus 1 into 7. It goes to plus 7. Then minus 6. Then plus 5. Minus 4. Plus 3. Minus 2. Like this. That means what happened? The amplitudes are go on decrease. And which oscillations is called? Damped oscillations. Damped oscillations. Omega d. System is stable. This is by the procedure. But the simple logic is this is by the procedure. Simple logic is whenever you are getting damped oscillations, what happened? Tell. Here, for example, what is the pole location? So real part is there. Real part minus zeta omega n. Pole. Imaginary part plus j omega d minus j omega d. So approximate response we want. What is the approximate answer? Even some constant k into V naught of t is directly we can write. I already told na C of t equal to what I can write directly, some constant k into e power minus zeta omega nd sine of omega dt. I can write directly. I already told how to draw response also. First you have to draw for real part. What is the response for real part? Tell. Exponential decay. Draw the response for exponential decay like that. Already I explained all these things. First draw the response for real part, exponential decay. It decays with the time constant of 1 by zeta omega n seconds. Reach the steady state by 5 tau. And fold with respect to 0. Same envelope will get below 0. Fold with respect to 0. You should fold because impulse means what? 0. Impulse means other than t equal to 0, it is 0 only. Other than t equal to 0, it is 0. So fold with respect to 0. Step means you have to fold with AK, steady state value. Step means you have to fold with AK, that is steady state value. Step means you have to fold with respect to AK. Impulse means you have to fold with 0. In between, make it oscillations. In between, make it oscillation. That's all I already told. These are called damped oscillations denoted by omega d. What is omega d? Omega n root of 1 minus zeta square, zeta radians per second. System is what? 100% stable. 100%. That means what is the conclusion, final conclusion? When zeta greater than 0, less than 1, poles lies in the left of S plane. Poles lies in the left of S plane, which are complex conjugate. Which are complex conjugate. Complex conjugate. System is stable. System response is exponential decay and frequency of oscillations. Exponential decay and frequency of oscillations, which are called underdamped oscillations, which are called damped oscillations. System is called underdamped system. Maintaining damping is called underdamped system. Maintaining damped oscillation, that's why it is called underdamped system. That's all. Okay. So take the break. 10 minutes break you take. After the break, I'll continue. Okay. Take the break. Right. Okay. Next. What I told, man, zeta greater than 0, system stable, I told. Less than 1 is greater than 0 or not? Huh? What you are, man? Greater than 0 means stable only. What I told? Read the statement. What is the statement I told? Stable for what? Zeta greater than 0. 1 is greater than 0 or less than 0? Huh? Simple logic. Hmm? Right. Next. Case 3. Case 3. Zeta equal to 1. Critical damped system. Critical damped system. Zeta equal to 1, critical damped system. Critical damped system. So now come on, zeta equal to 1 is substitute in the C of S. What is C of S? Omega n square by S square plus 2 into zeta 1 into omega n s plus omega n square. This can be written as omega n square by s square plus 2 omega ns plus omega n square. Can be written as omega n square by s plus omega n whole square. So now represent the what are the pole locations tell? S1 comma S2 is minus omega n minus omega n. Represent the poles in the S plane. So 2 poles S equal to minus omega n. So what happens? System stable or unstable? Stable. Time constant 1 by omega n seconds. No imaginary part means frequency of oscillations are 0. 0 radians per second. The system is stable. Left hand side system is zeta positive means stable. That's all. Stable. Now find the C of t. What is C of t? Tell. Apply inverse Laplace transform. Find C of t. What is C of t? Omega n square t e power minus omega n t. Yes or no? So C of t is omega n square into t e power minus omega n t. Default u of t. T e power minus omega n t, default u of t. Now draw the response. T e power minus t. How to draw response? I already explained in the basics. Ramp signal. You should be perfect in basics. You should read 3-4 times. Ramp. Product with exponential decay. I already discussed. What is the response? It rises and decays. This is C of t. You can take 0, 1, 2, and so on up to 10. Here like 10, I explained already 9, 8 up to 0. Product 0 into 10, 0. Next 1 into 9, 9, 2 into 8, it go on increases like this. It increases and decreases exponentially. It increase and decrease exponentially. This is the exact response of critical damped system. Critical damped system. Critical damped, it is having lowest time constant. It reaches steady state very quickly. Compared to all the system, critical damped is having the less time. So this is the response for critical damped system. It is rises. It is just like trying to make it oscillation, but it cannot repeat because frequency of oscillations are 0. Just like it is off cycle, but it cannot be repeated because frequency of oscillations are 0. What is the conclusion? When zeta equal to 1, both the poles lies in the left of S plane. Both the poles lies in the left of S plane, which are repeated. Which are repeated. When zeta equal to 1, both the poles lies in the left of S plane, which are repeated. Which are repeated. Both the poles lies in the left of S plane on the real axis, right? Both the poles lies in the left of S plane on the real axis. On the real axis, and which are repeated. Which are repeated. The system is stable. The system response is called critical damped system. The system response is called critical damped system. That's all. Next case. Case 4. Zeta greater than 1. Over damped system. Zeta greater than 1, over damped system, overcoming the damped oscillations is called over damped system. Zeta greater than 1, over damped system. Come on. What is C of S? What are the roots? Already we find the roots for this. What are the roots? S1, S2 minus zeta omega n plus or minus omega n into root of zeta square minus 1. These are the roots for over damped system. Now locate in the S plane. Come on. Locate in the S plane. locate in the S-plane. One pole is here, minus zeta omega n plus omega n root of zeta square minus 1. Minus zeta omega n minus omega n root of zeta square minus 1. The pole which lies near to imaginary is called dominant pole. This is called dominant pole. The pole which lies leftmost side is called insignificant pole. Insignificant pole, dominant pole and insignificant pole. So this is goes to leftmost area. This will come close to the origin. Now what is the time constant tell? It is just like insignificant pole only. It is like dominant pole. What is the time constant? -1 by dominant pole location. -1 by this means we'll get 1 by zeta omega n minus omega n root of zeta square minus 1 seconds. Frequency of oscillations equal to 0. The system is 100% stable. The system is 100% stable. Now find C of t, all of you. You find the C of t. Come on. Find C of t. What is C of s can be written as? C of s can be written as omega n square by s plus zeta omega n minus omega n root of zeta square minus 1. S plus zeta omega n plus omega n root of zeta square minus 1. This is the C of s. This is a what? Dominant pole. This is like what? Just like some constant by s plus 1 into s plus 10. Take this term, substitute in second, take second term, substitute in first, you will get the partial fractions. Get the partial fractions here. So for example, this can be written as what? This term make equal to 0. What is the s I will get? S equal to minus zeta omega n plus omega n root of zeta square minus 1. This is substitute here. If I substitute here, what happened? Minus zeta omega n plus zeta omega n getting cancelled. Then this will become 2 times. Then if you find the root, you will get the partial fractions. You find omega n by 2 root of zeta square minus 1 you will get. You substitute this here. Minus zeta omega, this cancel. This is 2 times of omega n root of zeta square minus 1. 1 omega n cancelled. Then you will get omega n by 2 root of zeta square minus 1 into 1 by s plus zeta omega n minus omega n root of zeta square minus 1 minus omega n by 2 root of zeta square minus 1 into 1 by s plus zeta omega n plus omega n into you will get opposite sign here. Root of zeta square, partial fractions, you find it. Take this term, substitute here. Take this term, substitute here. In the s you substitute. Take this term, you substitute in the s, you will get here minus omega n by 2 root of zeta square minus 1 you will get. Then apply inverse Laplace transform. C of t equal to omega n by 2 root of zeta square minus 1 into e power minus zeta omega n. That means minus zeta omega n minus, this is s plus a na. So s plus a means e power minus 80 minus a means omega minus omega n root of zeta square minus 1 into t minus omega n by 2 root of zeta square minus 1 and e power minus bt zeta omega n plus omega n root of zeta square minus 1 into t. So this is the response. Here this first term is called dominant pole response. DP means dominant pole response. Second term is called insignificant pole response. So we can neglect this. Why? Because this response become very, very small. If I draw the exact response, if I draw the response here, T0, what I will get? T0 means you will get what? Substitute T0 in the dominant pole. This will become T0, e power 0 becomes 1. You will get this. So that is omega n by 2 root of zeta square minus 1 or 0. Next, T infinity 0. That means exponential decay. That means exponential decay. So this is what dominant pole response. Minus insignificant pole response. Omega n by 2 root of zeta square minus 1. Insignificant pole is lies leftmost side na. Time constant very, 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 very small. This is time constant very, 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 very large. So insignificant pole, time constant very small. This is insignificant pole response. Time constant very, very, very small. Here time constant very, very, very large. This is phi tau only. This is phi tau. Either you subtract this, in case if subtract and draw the response, I already discussed dominant pole, insignificant pole concept. If I draw it, C of t becomes, it will rises like this and decays exponentially. Like this. Decays exponentially. This is exact response. Exact response of OD means overdamped system. Exact response of overdamped system. but this is approximately simply dominant pole response. Approximately dominant pole response. Approximately dominant pole response. Approximately dominant pole response. Dominant pole response. That's all. So here what happened? There is no more oscillations. There is no more oscillation. That's why they called overdamped. Over means overcoming the damped oscillations. Overcoming the damped oscillations. That's why they called overdamped system. What is the conclusion? Tell when zeta greater than 1, the poles lies on the real axis. The poles lies on the left, lies on the real axis at different locations. At different locations in the left of the S-plane. In the left of S-plane. The system is stable. The system response is called overdamped system. That's all. This is all about the what? Impulse response. So just what we did, we taken different values of zeta, we drawn the responses. But we'll make the summarize some conclusions. That conclusions are very, very important. Okay. So now summary. This is very, very important. Summary. Summary. Listen, this is very, very important. Listen. 0. When zeta 0, the poles lies on the imaginary axis. Zeta 0 plus j omega n minus j omega n. System is called undamped system. Undamped system. So when zeta 0, system is called undamped system. System response is oscillatory. Time constant is infinity. Frequency equal to omega n. System is marginal stable. This is complete information of marginal stable system. When zeta 0, undamped system, oscillation, constant amplitude, frequency of oscillation, time constant infinity, system is marginal stable. Okay, na? Next, when zeta increases, what happens? When zeta increases, what happens? Listen. When zeta increases, the poles moves towards the left hand side like this. When zeta increases, the poles moves towards the left side. Like this. Right. One minute. 1 minute. Right. Right. Listen, all of you. Listen. What is this line represents? Tell anybody. Why I drawn a circle? Anybody? Listen here. When zeta increases, listen, as zeta increases, both the poles, when zeta increases, both the poles moves towards the left. Both are moves towards the left and near to the real axis. Both the poles moves towards the left and near to the real axis, and both the poles enter into the real axis. Both the poles enter into the real axis when zeta equal to 1. Both the poles enter into the real axis when zeta equal to 1. System is called critical damped system. System is called critical damped. System is called critical damped. The pole location is S equal to minus zeta omega n. So as zeta increases from 0 to 1, the poles moves towards the left and near to the real axis. And it enter into real axis when zeta equal to 1 at S equal to minus omega n. At S equal to minus omega n. What is the nature tell here? The critical damped nature, just now only I told. C of t is what? It is increases as well as decreases exponentially. It increases as well as decreases exponentially. Decreases exponentially. Decreases exponentially. Increases and decreases exponentially. Next, what is the time constant tell? 1 by omega n seconds time constant. Frequency of oscillation is 0 radians per second. 0 radians per second. So this is the complete information about the what critical damped system. When zeta is greater than 0 and less than 1, the poles will be mid-path of along this semicircle. When zeta greater than 0, less than 1, you will find the poles along this midway of semicircle. So if zeta is 0.1, the poles going to be placed very close to the imaginary. In case zeta 0.9, the poles are going to be very close to the real axis. If I select the zeta mid value like 0.4 or 0.5, you'll find the poles along the midway of this circle. Along the midway of this circle. Along the midway of this circle. Along the midway. If you zeta like 0.4 or 0.5. Then like this. Like this. Then here the real part is minus zeta omega n. In this case, real part is minus zeta omega n. Imaginary part is plus j omega d. Minus j omega d. Minus j omega d is the imaginary part. Minus j omega d is the imaginary part. Then this is for what? Zeta greater than 0, less than 1. System is called under-damped system. System is called under-damped system. What is the nature tell? The nature is decreasing amplitude oscillation. The nature is decreasing amplitude oscillations like this. 0. Like this, decreasing amplitude oscillations like this. Decreasing amplitude oscillations. Time constant equal to, what is the time constant here? 1 by zeta omega n seconds. Frequency of oscillations equal to omega d. That is omega n into root of 1 minus zeta square. Radians per second. This is the what? Frequency of oscillation. This is a complete path of the pole when zeta increases from 0 to 1. In case poles comes very close to real axis, zeta for example 0.9. In case poles zeta is 0.9, means poles are very close to the real axis. What should be the nature in this case? Imaginary part is very less. Imaginary part less means what? Frequency of oscillations are less. Imaginary part less means frequency of oscillations are less. So you'll get the response like this. So that means oscillations are very, very less. Time durations are large like this. Like this. Oscillations are very less. Time durations are large. Like this you will get. Like this you will get. When poles are very close to the imaginary, frequency of oscillations are very, very large. This is a complete path of the pole when zeta greater than 0 and less than or equal to 1. Still the zeta increases, what happens? Still the zeta increases, what happens? So what happens if still zeta increases? One pole come to left like this. One pole come to left, leftmost it will come. Another pole moves towards the origin. Another pole moves very close to origin like this. So one pole leftmost, one pole close to origin. What is this pole location? Tell now. What is this pole location? This is for zeta greater than 1. System is called OD. OD means overdamped system. What is the location of this pole? Tell. Minus zeta omega n plus omega n root of zeta square minus 1. Root of zeta square minus 1. It is a overdamped system. Overdamped system. What is the nature? Tell here. The nature is, this is T0. It will increase and then decrease exponentially. This is the nature. Exact nature of overdamped system. This is exact nature of overdamped system. Overdamped system. Exact nature of overdamped system. This is. So now what is the time constant tell here? Time constant equal to 1 by zeta omega n minus omega n root of zeta square minus 1. This frequency equal to 0 radians per second. This is the complete information about the what? Overdamped system. This is a complete information about the overdamped system. This is a complete path of the pole when zeta increases from 0 to greater than 1. Greater than 1 means what? Greater than 1 means what? Up to infinity. This pole never going to be enter into origin. It will lies always left hand side only. Why? Because the negative value minus zeta omega n value is larger than plus omega n root of zeta square minus 1. This pole comes very close to origin, but it never enter into the origin. That means system always stable only. It is always stable only. This is complete path of the pole when zeta increase from 0 to infinity. In case zeta reduced, what happened? If zeta reduced, the same pole moves to the right. Same pole moves to the right. For example, if I take zeta here plus 0.5, if I take minus 0.5, exact symmetrical pole will placed in the right of S plane. Exact symmetrical pole placed in the right of S plane. Like this. Exact symmetrical poles in the right of the S plane. What is this location? S equal to plus zeta omega n. S equal to, I can say minus zeta omega n only. Why? Because zeta negative na here. What is zeta? Less than, what is zeta here? Zeta reducing na? We are reducing the zeta. So that means what is zeta? Bolo? Greater than minus 1 less than 0. Greater than minus 1 less than 0 zeta. And the zeta negative, negative becomes here positive. So automatically you'll get the positive. In case zeta equal to minus 1, for example, here zeta equal to what? Minus 1. Then poles enter into positive side at plus omega n. Here no zeta, na, that's why I written plus omega n. So then again still that means as zeta go on reduce, the poles are going to it towards the right side. The poles are symmetrical poles. Exact symmetrical poles come to the right side. Exact symmetrical poles come to the right side. So then still zeta reduce, one pole come to the what? Close to the imaginary. Another pole moves to the rightmost side. Another pole moves to the rightmost side like this. This is for zeta less than minus 1. This is also for zeta less than minus 1. So what is the response for zeta less than minus 1? Either one pole right or many poles right, the response is exponential rise to infinity. What is the final conclusion tell? The poles which lies in the right always system is unstable. That means zeta negative unstable. The poles which lies in the left always stable. The poles which lies left always stable. Left hand side always stable. Right hand side always unstable. Left is stable always. Right is unstable. Right hand side is always unstable. Left is always stable system. So this is the what? Complete path of the pole when zeta increases from minus infinity to plus infinity. This is complete path of the pole when zeta increases from minus infinity to plus infinity. Okay. So now it is required for a special objective bit. They used to ask us some theory questions or certain reasoning questions. This is what? A path of a single system. Which system? RLC circuit. In which what is variable? R is variable. Zeta varying means R is varying. Zeta varying means R is varying. R is varying. Just R is varying. In RLC circuit, just by changing the R value, the poles are going to be move like this. Just by changing the R value. LC fixed. R0 mean what is zeta tell? Zeta equal to R by 2 root of C by L. LC constant. R0 means zeta 0. Poles comes on imaginary. So are increasing, poles are coming to left, still increasing, poles come to the real, still increasing, poles are moving toward the what? On the real axis. One is left, one to near to the origin. But right hand side only theoretical analysis, because right hand zeta never be negative. Na? Practically zeta is always positive, because R is positive, C is positive, L is positive. So zeta always positive only, zeta is positive. So that means the poles always lies in the left hand side only. For theoretical analysis only, we drawn poles in the what? Right side. 1 minute, sorry. Next, conclusions. Conclusions are very important compared to this diagram, and based on this diagram only we'll write the conclusion. That conclusions are very, very important for objective type bits. Right. Now write the conclusions. Next. Conclusions. Come on. What is the first conclusion? What is the second order system poles path? Anybody? What is the second order system poles path? Anybody? It is not a unit circle. Yeah. It is not a jet plane. It is only S plane only. It is a circle, that's all. Yes, circle. Right, it is a circle. Write it. So what is the first conclusion? When zeta Bolo, first conclusion tell, when zeta increases from -1 to +1, the second order system's poles path is the second order, or the system, the second order system poles path is circle. System poles path is circle with a radius of omega n. Dekho, here what is the radius tell? Here also omega n, here also omega n, here also omega n, here also omega n. Anywhere pole is there. For example, what is the distance tell? Here to here, what is the distance? The distance is how much tell? This distance is how much? What is the distance tell? Omega n. The distance is omega n. So when zeta increase from -1 to +1, the second order system poles path is circle with a radius of omega n. And one simple bit, one simple problem. Note down this question. The zeta value to the given pole's location is the zeta value to the given pole's location is tell the answer. Tell the answer. Come on. What is the zeta value? Option A. Zeta greater than 0, less than 1. Option B. Zeta greater than -1, less than 0. Option C. Mod zeta equal to 1. Option C. Mod zeta greater than 0, less than 1. What is the answer? Anybody? Tell the answer. D. D is the answer. Answer is D. Whenever the poles lies left and right, which are symmetrical about imaginary, you need to consider modulus of zeta. Whenever poles lies left and right, which are symmetrical, you need to consider modulus of zeta. Mod zeta greater than 0 and less than 1. So we need to consider modulus of zeta. Okay, na? Next, second point. Second point. What is at least give one conclusion by looking this? One conclusion you tell. What is the second conclusion? When zeta greater than 0, less than 1, the second order pole, the poles moves towards the left. The poles moves towards the left. Towards the left and near to the real axis. And near to the real axis. Yes sir, now observe here, the poles moving towards the left and near to the real axis. Both are moving left now, like this. Both are moving left and near to the what? Real axis. Near to the real axis. So what happened? In this case, near to the real axis. In this case, first one you tell. First conclusion you tell. What happened? As the poles moves left and near to the real axis, the first one you tell, time constant decreases. Time constant is decreases. Time constant is decreases. Second one, settling time decrease. Settling time, time constant, both the time settling. Settling time directly proportional to the time constant. That's why settling time also decreases. Settling time is decreases. Next, third one, damped oscillations omega d decreases. Damped, this is called omega d. This is omega d, omega d. Here only omega n. Once it comes left hand side, damped oscillations. So omega d decreases, damped oscillation. What is omega d on the real axis? 0. Here omega d is 0. That means omega d decreases. Damped oscillations. Damped oscillations. Damped oscillations, omega d decreases. Omega d is decreases. As omega d decreases, what happened? Tell. As omega d decreases, what happened? The time specifications, time opposite to frequency, na? The time specifications, what are that? Delay time, rise time, peak time, all are increases. Delay time, rise time, peak time, all are increases. Once omega d decreases, blindly we can write that delay time, rise time, peak time, all are increases. Delay increases, rise increases, peak time increases. All are going to be increases. Next, the system becomes more relative stable because poles coming to left, na, the system becomes more relative stable. System becomes more relative stable, because poles are moving toward the left now. More relative stable. Poles are more relative stable. That's all. This is 2 seconds. When zeta increase greater than 0 and less than 1, all these factors are going to be occurs in the system. So time constant decrease, settling time decrease, damped oscillations are going to be decreases, and time specification, delay time, rise times, peak times, all are opposite to the omega d increases. System becomes more relative stable. The system becomes more relative stable. Next, third one. Third. Bolo. What happened? When zeta equal to 1 and greater than 1, what happened? When zeta greater than or equal to 1 and increases, what happened? Greater than or equal to 1 and increases, and increases. Then what happened? Then one pole moves towards the origin, One pole moves towards the origin. One pole moves towards the origin. So in this case, what happened? In this case, first one, what happened? First one, poles moving towards the origin means what happened? Pole are moving towards the origin like this. Pole are moving towards the origin. What happened? First case, time constant going to be increased. Time constant increases. Second one, settling time increases. Third one, damped oscillations become 0 because it is on the real axis now. Damped oscillations becomes the 0. There is no more damped oscillation. The system does not consist any oscillations when zeta greater than or equal to 1. System having oscillations only when zeta greater than 0 and less than 1. Zeta greater than 0 and less than 1, then only the system maintain the oscillations. In case zeta greater than 1 and increases, the system does not consist any more oscillations. Omega d becomes the 0. And the system becomes less relative stable. System becomes less relative stable. That's all. Next, fourth conclusion, last conclusion. Order of time constants. Bolo, which system having largest time constant? Order of time constants. Bolo, which is having highest time constant among this? Tell. So first, infinity, undamped system. Next, overdamped system time constant very, very large. Next, underdamped. Next, critical damped. So first highest time constant is tau of undamped system. Undamped system time constant very, very large. What is the time constant for undamped? Tell. Infinity. Time constant for undamped is infinity. Next, which is greater than time constant of overdamped system? Time constant of overdamped system. What is the time constant for overdamped? 1 by zeta omega n minus omega n into root of zeta square minus 1. This is overdamped system. Next, which is greater than what? Tell. Time constant of underdamped system. Next highest time constant is underdamped system. What is the time constant for underdamped system? 1 by zeta omega n. 1 by zeta omega n. So 1 by zeta omega n. Least time constant is what? Tau of critical damped system. Tau of critical damped system. Critical damped system having the lowest time constant. Critical damped system. Critical damped system. What is the time constant for critical damp? Tau equal to what? 1 by omega n seconds. 1 by omega n. And one more thing here. This undamped system is what? Marginal stable system. Marginal stable. Remain all the systems are stable systems. Remain all the systems are stable systems. Under undamped system is a marginal stable system. Remain all are stable systems. In a stable system which is having largest time constant, overdamped system. Overdamped. The system which is having largest time constant, largest tau is called what? The system which is having largest time constant is called slow response system. Slow response or sluggish systems. Sluggish. SLUGGIS. Sluggish systems. Overdamped systems are called slow response systems or sluggish systems. Underdamped system having medium time constant. Medium tau. Critical damped system having the what? Smallest time constant. Critical damped system having the smallest time constant among all. This is the order of the time constant. Okay, this is the order of time constants of second order system. Mostly we'll use only underdamped system. The best system is what? Underdamped system. What is the best range of zeta? Anybody? What is the best range of zeta? The best range of zeta. What is the best range of zeta? 0.4 to 0.7. Generally, the best range of zeta is between 0.4 to 0.7. We don't select even very close to 0. We don't select even very close to 1. It will come later. I will discuss it. Why we'll select the underdamped system? Why the underdamped system is most preferable? That and all will come. Okay. So next we have to start the unit step. And one more thing. Whatever the theory we discussed, whatever the points we discussed from this diagram, these conclusions, all are valid for step response also. All these points, whatever these 4 conclusions I given, these 4 conclusions are valid for step response also. For step also it is valid. For step also it is. I am not going to discuss any more theory for the step response. For step, just I'll go on, draw the responses. For zeta 0, just I'll draw the response. Zeta greater than 0, less than 1, I'll draw the responses. Just I'll draw the responses and we'll start the time domain specification. But I'm not going to discuss all this theory because same theory valid for step and ramp for any input. Second order system nature completely depends on zeta, but not the input. It never depends on the what? Input. Second order system nature not depends on the input. It depends on only zeta. It may be step, it may be ramp or any input. The nature is not going to be changed. That's why irrespective of all the inputs, zeta 0 means we'll call undamped system. Zeta greater than 0, less than 1 means underdamped system. Zeta equal to 1 means critical damp. Zeta greater than 1 means overdamped. These names are not going to be changed with respect to input. The names, the nature depends on only zeta value. Okay, na? Okay. So I'll close here. If we start the next topic, it takes half an hour. That's why I'll stop here. Okay. So if you have any doubt, you can ask. Tomorrow we'll start sharp 6 o'clock. Worst case 6:05 will start. Okay, I'll close here. If you have any doubt, you can ask. You can raise the hand. Nilansha.
Hello, sir. I have a doubt in 22F. 20F, sir. 20. Sir, in second, sir, in second point, you told that if we move from, if we move towards the real axis, that is towards the left, then tau is decreases. Sir, can't it be increasing like because we move we move far apart from real axis?
What is the tau left hand side? As you move toward the left, what is the tau?
It increases.
Huh?
No, it decreases. It decreases.
That's all.
Okay, sir. Okay, sir. Get that. Thank you, sir.
Sir, no.
Yes, sir. Yes, sir.
Okay. Karthikeya.
Good evening, sir.
Good evening. Tell me.
Sir, the system response of critically damped and over damped, sir, are kind of same, sir. If a question comes of graph and they match the following question type.
Over damped, critical damped is just like sine wave only, na? It increases and decreases. Critical damped main thing is the time constant very, very small. It reaches steady state very quickly.
So, sir, if the time tau,
Tau
if
is
it is
very small for critical damped.
Sir, if it is less in the graph, then we can select critically damped.
Huh?
Sir, I'm asking if they give graphs and they ask what time, what is the, if it is a underdamped, overdamped, or critically damped response based on the graph. So by the time constant, we can say that it is if time constant is more than it is overdamped, and if it is less, then it is critically damped. Okay, sir.
Correct only. Overdamped having largest time constant.
Okay, sir. Okay.
Akansha. Hello?
Hello?
Tell.
Sir, overdamped has largest time constant or undamped?
Overdamped having large time constant.
Sir, but in order we wrote undamped has.
Huh?
Sir, while we are writing order, fourth conclusion.
Tell.
Sir, here we saw that time constant.
Loudly.
Pardon?
Speak loudly. Voice coming very low.
Hello?
Tell loudly. Hello?
Hello?
Tell.
Sir, here we saw that time constant of undamped is largest. So I was asking that in
Time
MCQ.
constant of undamped how much?
Infinity.
Infinity larger only, na?
Yes, sir. So if it will be asked, then we will write overdamped or undamped.
Undamped only. Undamped infinity, largest among all.
Oh, because you have written largest tau of overdamped, means sometimes you were referring overdamped.
In a stable system, which is the largest means overdamped.
Okay.
I written in the stable system, which is the largest.
Okay, sir, got it. And sir, while we were deriving for overdamped, while doing partial, why didn't we consider only the dominant pole and ignored
We
the
can
other?
consider, just for explanation, I taken both actually. We can take it directly only. To
So
draw
then
that exact response of overdamped, I consider both. Otherwise, directly we can neglect the insignificant pole.
Then the amplitude was changing when I ignored the
Which amplitude?
Sir, like omega and pi 1 minus omega.
This
square.
one.
Yes, sir. This amplitude.
Why you need this? Some constant to consider, that's all.
Okay, it won't matter.
It is not a matter.
Okay, sir. Sir, and in ramp response for first order, you said that T minus tau is steady state.
Yes.
So, but how is it steady state?
Is it going to become 0? Substitute t tends to infinity, is it 0?
No, sir.
Well, then it is steady state.
Okay, means it is not necessary that amplitude will remain same.
No. Amplitude not, that is not compulsory. Transient means simply t tends to infinity substitute, it should become 0. Steady state means remain, all terms are treated as steady state only.
Okay, sir. Got it. Thank you, sir. Natasha,
Hello, sir.
tell.
Sir, 20F, I think. No, sir, 21F. Sir, here, after zeta is greater than 0, one pole moves towards the origin and the other pole moves towards...
Leftmost means that is called insignificant.
Okay, so that's why we are not considering that.
That's why we don't consider that.
Okay, sir.
Okay. Sanjeev.
So I want to know how the time responses of the system is related to omega d.
Omega d means what? Damped frequency of oscillations, na?
Yes, sir.
We are drawing RLC circuit gives the frequency or not?
Yes, sir. But how how it is related to the response time, delay time, and peak time?
We are how related to
delay time, rise time, peak time.
Peak time. Okay.
How omega d is related?
You will come next to that only, not time domain specifications. Formulas will come.
Okay, sir.
Okay, na? Abdul.
Sir.
Atel already closed. We didn't raise that. Atel.
In underdamped ఇప్పుడు ఏది అంటే స్టేబుల్ ఇప్పుడు మోస్ట్ స్టేబుల్ అండ్ ఓవర్ డామ్ కి ఇప్పుడు మనం ఏది తీసుకుంటాం సార్ అంటే స్టేబుల్ సిస్టమ్ లో మోస్ట్లీ అంటే రెస్పాన్స్ కి
అండర్ డాంప్డ్ ఇట్ విల్ కమ్
అండర్ డాంప్డ్ తీసుకుంటామా
under damped or critical damped, that's all. Both.
Over damped తీసుకోమా
over damped is unstable. One pole coming to near to less stable, na? One pole coming to origin, na? Near to origin it will come, na? Less stable.
Okay. అంటే టౌ ఎక్కువ ఉంటే స్టేబుల్ తక్కువ ఉంటది అంతే కదా సార్?
అంతే. టౌ లార్జ్ అంటే లెస్ స్టేబుల్.
ఓకే. అదొకటి.
Naveen.
Hello, sir. In zeta equal to 1 critical damping case, you taken S plus zeta omega n minus that one 0 you taken, no, sir?
Which one 0 I taken, man? Which page tell?
17F, I think. 17 or 16F.
This only?
Sir, screen.
This one, huh?
Not coming, sir. Not coming, sir. Screen. Yes.
I think. Now?
Now coming, sir. 16F or 17F you go.
Tell. Which case? Zeta?
Here, sir. C of S you started, no, sir. C of S. Here you taken S plus zeta omega n minus omega n root over zeta square minus 1. That
yes. Tell.
Why, sir, you taken 0?
Roots, that roots I written, na? S
okay.
equal to this one means, what is the equation? Tell. I expanded the omega n square by s square plus 2 zeta omega n s plus omega n square. I expanded when zeta greater than 1.
Okay, sir.
Okay, na?
Okay, sir. Then how you split it, sir? This one. Next step.
Partial fractions.
Okay.
Take this
For
term,
above one.
substitute here, you will get the
Okay,
first
sir.
constant term. Second, take this term,
Okay.
substitute here, yes, second term. Partial
Second
fractions, how
partial
will you
fraction.
find?
Okay, sir. Okay, okay, sir.
Okay, na?
Okay, sir.
Okay.
Okay, sir.